Hey guys, Miss Kilgard here, back for lesson 14. We're going to continue our work with exponents. Go ahead and go to joinmyquiz.com and enter code 1642463 so you can play the quizzes game. When you're done, come back to this video. We'll go over one of those tough questions. All right. So this question stumped some of you guys. Okay, it says Nate and Janet are asked to write an expression equivalent to 4 times the quantity 2x plus 2y. Nate writes 8x plus 8y, and Janet writes 8xy. Who is correct and why? To show you guys which kid is correct here, I'm going to go ahead and draw a model. So we have that width is 4, right? And one part is 2x. Oops, I wrote that a little bit messy. And the other part is 2y. Okay, so I can multiply 4 times 2x, and I'll get 8x. 4 times 2y, and I'll get 8y. I can't combine those because they have different variables. So I'm left with 8x plus 8y. All right, so definitely Nate is correct. Janet's expression here would mean 8 times x times y. And that would be different. If there's actually another way I could write this, I could factor out the 8 because they're both being multiplied by the quantity 8. And I could have 8 times x plus y, but that wasn't an option. I just want to show you that too. So Nate is correct because, there's 2 where Nate's correct. Okay. Because 4 times 2x plus 4 times 2y equals 8x plus 8y. That's definitely true. Nate is correct because 4 plus 2x plus 4 plus 2y, nope, that does not equal 8x plus 8y. What they want you to think here is that you're adding this 4, but that means multiplication. And if I was to simplify this here, I would add the 4s, because I would add without a variable. I would have 8 plus 2x plus 2y. That's different than what they said. So, nope, not true. And Janet is just wrong. All right, go ahead and jot down any notes you want about that. When you're ready, press play. We'll move on. If you haven't grabbed your workbook or your notebook, this is a good time to do that. You can also look at your comments on the last lesson slides. I gave you some feedback. Okay, so let's go over that exit ticket. And again, if you haven't seen your feedback, you can go ahead and look at that now. A lot of you guys did a great job with this. It says Andre and Elena knew that after 28 days, they would have 2 to the power of 28 coins, but they wanted to figure out how many coins that actually is. Andre wrote 2 to the 28th is equal to 2 times 28 is equal to 56. Elena said, no, exponents mean repeated multiplication. It should be 28 times 28, which works out to be 784. Do you agree with either of them? Explain your reasoning. So, most of you guys were able to figure out that Andre was wrong because 2 to the 28th, actually, I'll go back. 2 to the 28th does not mean that you're multiplying 2 times 28. It means 2 28 times, okay? That means I'm going to have, some of you guys even wrote this out, which is awesome. 2 times 2 times 2. Let me actually start earlier. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so I don't expect you to evaluate this because that would be a lot of multiplication. But what we'll see here pretty quickly is, okay, so let's evaluate some of it so we can see that 56 is not a reasonable answer. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So already by here, we're at 64. So 56 is not a reasonable answer. So Andre is definitely incorrect here. Elena said, no, exponents mean repeated multiplication. This part is true. It should be 28 times 28. This part is false. it's not 28 times 28. You take that base number and that's what you multiply. So what she was thinking of is 28 to the second power, and you cannot flip it with exponents. And she was correct that 28 times 28 is 784, and that did kind of confuse some of you guys, I think. But Andre's also correct that 2 times 28 is 56. But neither kid is answering this question correctly. Okay, this is the question you had to solve, not 28 times 28. Okay, so do you agree with either kid? No, we do not agree with either kid. And the reason why is because we would have to multiply that 28 times, and you would get a really large number. It's in the thousands. Okay, so definitely neither one of those kids is correct, because while exponents do mean repeated multiplication, you have to multiply that base number, the 28 times, not 2 times 28 or 28 times 28. Okay, so go ahead and jot down anything you want from that. When you're ready, press play and we'll move on. All right. So today we're finding the value of expressions with exponents. Your goals for today are to know how to evaluate expressions that have both an exponent and addition or subtraction, and know how to evaluate expressions that have both an exponent and multiplication or division. So just working more with exponents. All right, so we're going back to the cube. We've actually seen this before. Okay, so this is familiar to you. So if you're ready, you can go ahead and pause here and fill in as much of that table as you can in your workbook if you have it, or if not, just jot it down on a piece of paper. When you're ready, press play and we'll move on. Okay, so we're looking, okay, the side length of the square is 3. So the area of the square, I could write it, as, if I'm writing it as a number, 3 times 3 is 9, right? Where's my pen here? There we go. Sorry. Okay. And the volume of the cube, I would do 3. So I did 3 times 3 and I got 9 for the area of the square. I do length times width times height. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So the volume of the cube is 27. Oops, I should have put units squared and units cubed because I'm talking about volume. Now the surface area of the cube is when I find the area of each of the sides and I add them all up. I know that the area of this, 3 times 3, is 9. And I know that a cube has 6 sides. 1, 2, 3. 1 back here, 4. 1 back here, 5. And 1 down here at the bottom, 6. So I can use 9 times 6 to figure that out. I know that 9 times 6 is 54. So I'll have 54 units. And because it's area, I'm writing squared. All right. Now I want to use it as an expression using an exponent here. So I have 2 3's multiplied by each other to find the area of that square. So I could write 3 squared. That's also equal to 9. 3 squared. I still write units squared. That's how I write about area. My dog is doing something really weird. I don't know what he's doing. Sorry. Okay, so now let's look at the volume of the cube. I have 3 3's, right? 1, 2, 3. Length times width times height that I'm multiplying. So I could write 3 to the power of 3. Now this only works because all the sides are the same because it's a cube and a square. Okay, this won't always work. 3 cubed, units cubed again because I'm talking about volume. And now for that surface area, I know that I found the area of this square here. I'm going to change my color so you can see it on this. But I used 3 times 3, right? And I know that's the same as 3 squared. And then I multiplied it by 6 because there's 6 faces. So 3 squared times 6 units squared. Okay. Go ahead and jot down anything you want from this slide. When you're ready, press play. We'll move on. Okay. And we went through it already. Okay. Sorry, I forgot to delete those from when I did this in class with you guys. Okay. Let's move on to calculating surface area. So a cube has a side length of 10 inches. Jada says that the surface area of the cube, sorry, my dog is really messing around right now, is 600 inches squared, and Noah says the surface area of the cube is 3,600 inches squared. Here's how each of them reasoned. So they were looking at the same cube, and they have totally different answers. Okay, so we need to figure out which kid is right here. Jada or Noah, or neither. You could agree with neither. So take some time and work out this problem. Maybe draw a table like we used in the last situation and determine if which of these kids or if either of them you think is correct. I'm going to give you, a visual to work with here. So if we have a cube, I think sometimes it's way easier if you can see it. And we know each of these is 10, 10, and 10. All those side lengths are 10. Okay, so now go ahead and try and solve for which one you think is correct and explain how you know, either in that workbook or in your math notebook if you have it. Okay, so hopefully you had enough time to solve. Again, it's not a problem. It took you like a long time to deposit. So let's go ahead. We figured out to find the surface area. We would first find one of those faces. Okay, and since it's a cube, we know all the faces are the same. This works really well for a cube. To find the area of this side, I need to use 10 times 10 because this length here is 10, this length is 10, this length is 10, 10, 10. So side by side for that area of a square, right? And I can write that, another way I can write that is 10 squared, okay? And I know that 10 times 10 is 100, all right? But I'm not looking just for the area of one square. I know there's one square here, one square here, up here on the top, this side, and the bottom, right? So there's 6 faces I have to account for. So I have to take whatever quantity I get and multiply it times 6, okay? So I'm going to have to figure, I know that 10 squared is 100. And I'm going to take 100 and multiply by 6, and I'll end up with 600 inches squared there. And which kid did my work match? My work matched Jada's method. Here's where Noah went wrong, okay? Noah, we learned with like PEMDAS or GEMDAS or any of those methods that you have to evaluate the exponents first. Noah didn't evaluate the exponents first. First, he multiplied, but like if we're looking at PEMDAS, okay, and this isn't my favorite way to think about it, but it kind of helps you to remember the rule if it's having a hard time sticking for you. We're talking about the P, it's either like parentheses or grouping symbols. E is for exponents. The N is for multiplying, and the D is for dividing. These two have equal weight, so you just go whichever order comes first. And then these two are addition and subtraction, and again, equal weight, whichever one comes first, okay? So here, Noah did the multiplication first, but he should not have done that. He should have done it the way that Jada did it and evaluated the exponent first. And when I say evaluated the exponent, I mean take that 10 squared and turn it into that 100, like we did here when we multiplied 10 by 10, I got 100, okay? So hopefully you understand why Jada's method is the correct way to solve and Noah's method is incorrect, okay? Pause here and jot down some notes if you need to. When you're ready, press play and we'll move on. Okay. And we're going to skip the 3 reads because we do that when we're together. Sorry, I left that in. Okay, expression explosion. Okay, so I'm going to ask you to take about 10 minutes and solve as many of these as you can. If you can only solve one of the columns, that's fine. But if you're a kid that's ready for a challenge, go for both columns, okay? We all got nothing but time in the quarantine, right? So try and challenge yourself to solve as many of these as you can in 10 minutes. Set a timer and really try to get them all knocked out. All right, pause this video, solve as many of these as you can. And the answers in each row, that means going across, should be the same. So you could check your work if you're able to solve them all. That's pretty cool, huh? All right, pause here and get solving. When you're ready, come press play and I'll go over them. All right, so we're always going to do the exponent first. I'm just going to go ahead and jot down PEMDAS over here to help me remember the order. Parentheses are first, then exponents, multiplication, division have equal weight, whichever one comes first in the number sentence. Addition, subtraction, again, have equal weight as each other, whichever one comes first in the sentence. So we see the exponent here first. So I'm going to start with 5 times 5, and I'll get 25. Then I'm going to add the 4, and I'll get 29. So for this one, you should have gotten 29. Moving across, I have an exponent first, so sorry. I'm going to solve that first. 2 times 2 is going to be 4. And then I'm going to add the 25. And I will again get 29. So I know I got this correct. Yay! Okay. All right, let's move on. So I have 2 to the 4th power, which means 2 times 2 times 2 times 2. 2 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Then I'm going to multiply that by 5. 5 times 2 is 10, carry the 1. 5 times 3 is 15, plus 1 is 16. So I'll end up with 160. All right. So again, I'm going to do exponents first. I have 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 5. Whoops, my bad. I made a mistake on this one. I don't know what I was thinking here. Okay, let me go back and fix that. So I know that 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Then I would do 16 times 5. And instead of this, which is wrong, I have 30, and 5 times 1 is 5, plus 3 is 8. So I should have had 80. And that's why I love doing the whole thing, so I caught my mistake over here. Okay. Now I know 2 times 2 is 4, 4 times 2 is 8. And then I'm going to multiply that by 10. 8 times 10 is 80. Nice. Now I have the same answer on both sides, so I know I'm correct. Whew. All right. Moving and grooving. Okay, this one is a little tricky because I put the exponent second this time. You're still going to do the exponent first because of PEMDAS. All right. 4 times 4 is 16. Then I'm going to do 16 times 3. I don't have my 16s memorized. So 3 times 6 is 18. Carry the 1. 3 times 1 is 3, plus 1 is 4. So I'm left with 48 for this problem. All right, let's move on over here. Again, you're doing the exponent first. Even though it's second in the problem, it doesn't matter. The exponent always comes before multiplication. So I have 2 times 2 because 2 squared is 2 times 2. 2 times 2 is 4. And then I'm going to multiply that times 12. And 12 times 4 is 48. Yay, same answer both sides. Okay, let's go on. Again, exponent always comes first. Unless there's some grouping symbols, but we don't really have those here. We do down here, but they're kind of to trick you. Okay, so I have 2 to the third, so I have 2 times 2 times 2. And I remember 2 to the third is the same as 8. And I'm going to add 20, and I'll get 28. Okay, over here I have 3 to the third, and I'm always doing that exponent first. 3 times 3 is 9. 9 times 3 is 27. 27 plus 1 is, oops, that should be a plus sign there. Okay, is 28. Yay, same answer both sides. Okay. Now I have 9 times 2 to the first. For 2 to the first, that's just the same as 2 because you're just multiplying 2 by itself, but like no times because like you already have 1, 2 there. And so I would just write this the same as 9 times 2, and 9 times 2 is 18. Same thing over here. 3 times 6 is 18. Yay. Okay. This one they tried to trick you a little bit, but you're not going to get tricked. So I have, what they're showing you here is they don't want you to think that it's 1 cubed over 2. They want you to see that it's a half cubed. Okay, so you're still going to do the exponent first. So it's a half times a half times a half. And the nice thing here is we can remember that 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. So I have 1/8 times 1/9 because the 1/9 is from the problem. 8 times 9 is 72 over under 1. There. Okay. Same thing here. I'm going to evaluate that exponent first. A third times a third. 1 times 1 is 1. 3 times 3 is 9. Then I'm left with 1/9 times 1/8, just like before. And I'll get 1/72. There. Go ahead and pause here and jot down any notes you want to. When you're ready, press play. We'll move on. Okay. So some of them were definitely a little bit difficult with that parentheses there. Maybe you guys disagree. It's all right. Some of these are old bullet points. All right. Hopefully you guys by today are exponent masters. You've totally got this down under your belt. And you're ready to solve any exponent expressions that come your way. So let's dive into that exit ticket. Today in your exit ticket, you're going to be looking at Jada and Noah, our friends. Okay, so one of them is solving, and this is kind of similar to a problem that we did today, right? They know that the prism's volume is 20 cubic units, and they know it has the side lengths of 10 units. So they know the prism's volume, okay? And that's for a rectangular prism and then a cube, okay? Jada says the total volumes of both combined would be 27,000 cubic units. Noah says it's 1,020 cubic units. Here's how each of them reasoned, what the work they did. Do you agree with either of them, yes or no? Okay, just really it's important for you to note here that the value here that they're giving you is the prism's volume. They're giving you the volume. You don't have to solve for the prism's volume. For the cube, they're giving you the side length, okay? So for the cube, you are going to have to solve for the volume. All right, so make sure you're paying close attention to that as you solve. Go ahead and solve that on a scratch sheet of paper. When you're done and ready, you're going to bring that over to the exit ticket. Let me open that up. And you can go ahead and, oops, this is an old one. Sorry. I haven't made your exit ticket tracker for today yet. Sorry. I'll put that up. It'll be the same thing as always. Just start a new slide, put your name at the top, add a picture of your work, and you can get solving. I hope you guys have a great day, and I will see you on Zoom this afternoon. All right. Bye for now.